Hi all, this is going to be a short video to learn how to draw graphs, line and column. So the first thing that we need to remember when drawing graphs is step one, we have to identify whether it should be a line graph or a column graph, which are the two most common graphs that we'll use in science. So first you need to look at the data. Now, if the data is continuous, then you use a line graph. But you might be asking, what does continuous data mean? It means anything you can estimate between every single one of your data points. That's often numbers. So for example, 10 degrees Celsius and 20 degrees Celsius. That's continuous data because there's something that exists between that, which is 15 degrees Celsius. Whereas, if the data is categorical, you use a column graph. Now, it's easy for categories because you know that you can't estimate between them. So if I was trying to draw a graph on pizza toppings and the most common pizza toppings, and I have pepperoni as one, and then I have pineapple or ham and cheese or whatever, we know that those are two separate types of things. There's no sort of combined pepperoni pineapple one. So that's how our very first step is to try and identify what our data is. So if it's continuous, then we do line. If it's categorical, we do column. The second step is to follow the splat method. Now the splat tells you, and you should write every time you're doing a graph, you write splat just down the side of your page so that can help you remember what you need to have included in your graph and tick it off as you do it. So every time you graph, you should have scales on your two axes, and your scale should be even increments. And I'll show you how to do that in a moment, but it means that every box on your graph should go up by the same amount. So if it goes up by twos, it goes up by twos every single time. Then when you plot your data, if you're doing a line graph, you should have a small x for your line graph so that when you connect your line, you can still see your data points. Or if you're doing a column graph, you should have ruled columns, and especially with gaps. Okay, it needs to have gaps. You should always label your x and y axes, and previously you've learned about your independent and dependent variables, so always make sure your dependent variable is going on your y axis, and that will help you. Don't forget those units. Second last, we should always graph our averages and not trials if we're given multiple trials, so calculate the average to graph that. And then lastly, have a title. Your title should be clear and informative, and it should include the independent and dependent variable. So let's start practicing actually drawing some graphs. So here is our first set of data. We can see that we've got here the volume of water received each week for a plant and its growth height after 5 weeks. So one plant was getting 100 mils, one was getting 50 mils, and another was getting 25. And we can see those 3 trials, and we've got an average here. So let's do our first step. Do we have continuous data here? Well, if we have a look at 100 mils and 50 mils, is there something that exists between that? Well, 75. So we know that this is continuous data. And then if we have a look over here, the averages, 25, 16, 4, we know numbers exist between that, so that's also continuous. So that means that we are going to do a line graph. Okay, now that we've identified our graph, we need to plot our data. So you'll notice that I said before that we should always have our dependent variable on the y-axis. Now remember from the other video that we did on identifying variables, cows moo softly, I don't care. The thing I change is going to be my independent. The thing that I measure is my dependent. And then the things that I keep the same are my controlled variables. Okay, so what I'm changing here on purpose is the volume of water, so that's my independent variable. And what I'm measuring here is my growth height. So on my y-axis here, I should write growth height, and I should always have my units in brackets, centimeters. Then on my x-axis is going to be volume, and once again, have my units in brackets there as well. Okay, then what I'm going to do, so I've labeled my labeled my axes with units. I'm now going to create a scale first. But really, I'm going to do my scale next. And so I need to go from 100 to 25, so I have to fit all those numbers across this axis down the bottom. So I'm going to start at 0, and maybe I'll go... I could go up by 20s on this scale and it will fit. So see how every 5 boxes is worth 20. Now that's one way you could do it, or if you like, You could even go up by 25s, and then that will be really easy for you to plot your data. So then 25, 50, 75, 100. Okay? So I've gone up, every 5 boxes is worth 25 mils. Then what I'm going to do on this axis for the growth height, I need to get to 25 as well. So I might go every 5 boxes is worth, if I go 5, let's see if that works. 5, 10, 15, 20, 25. Works perfectly. Okay? So then what I'm going to do now is plot my data. So when my plant was receiving 100 mils of water, so here, its average was 25 for the growth height. So let's go to 100 and then go up to 25 and draw a small x. Then when my plant was only receiving 50 mils, it had 16 for growth. So 50. Now you might be thinking, where's 16? Well, if here is 15 and here is 20, it would go 16, 17, 18, 19, 20. So therefore, at 50, I should go 1 box up above the 15, and then that will be 16. Okay, and then for the 25 mils, I'll go to 4, which will be here. And then I'm going to get a ruler out, okay, and make sure that I connect these to each other using a ruler, okay. So I've now plot my data, I've created my scales, I made sure I only graphed my averages, and now I'm going to draw a title as my last thing. And it should be informative and include my independent and dependent variable. So here I could say the effect of different volumes of water on plant growth. Okay? And if I rub out all this other information here, you can now really clearly see my graph. And it's a line graph. Okay? Let's move on to the next one. So let's have a look at this graph here. So firstly, we need to see if it's continuous or if it's categorical data. So here, can you estimate between a tomato and a basil plant? No, because they're categories. So as soon as we see that, we know this has to be a column graph. Alrighty, then we need to think about, well, what's my dependent variable and what's my independent variable? So what's the thing I'm changing on purpose? Well, that's my plant species. And what's the thing I'm measuring? The average growth height. So then I'm going to go, here's my y-axis, here's my x-axis. On my y-axis, I'll have the average growth height of plant after 5 weeks in centimeters. So notice I put that in brackets, and then I'll put plant species down here. Okay, so we have labeled our axes with units. Now I'm going to create a scale for myself. So I'm making sure that it's even increments. So even for my bars, remembering that your bars have to have gaps. So I might go, I'm going to move across one box and write tomato. Okay, so I know that my bar is going to go there. I'm going to move across another box. Okay, and this is going to be basil, and you guys would all do this in ruler. And I'm going to move across another box and have coriander. Then I have to use this scale. Now I can't go up by 5s this time because I definitely won't fit. So I'm going to start at 0 and see if I can go up by, let's see, 10s. 20, 30, 40. That works perfectly, okay? Now I'm going to plot my data. So for the tomato, remember using a ruler, I need to go to 45. So we know that these boxes must each be worth 2 if this goes from 0 to 10. So 2, 4, 6, 8, 10. So I'm going to go here to 42, 44, and then that would be 46. So it must be in between those 2 boxes there. And using a ruler, draw my bar. Okay, now if it's hard to see your bar because it's on the lines, don't shade it in, but you can just do some lines through it like this so that you can clearly see where your bar is. Now for basil, it's 25, which once again is going to be perfectly between 2 boxes. Using a ruler so it's nice and straight, and then draw some lines through it so you can clearly see it. And then coriander, which is 30. And go across Okay, so now I've graphed my averages, I've done my scale, I've plotted it, got my labels, just need to draw a title. And species is that independent. We've got that growth over 5 weeks is our dependent variable. So there we go. That's a basic rundown of how we can draw some graphs in science, line and column graphs. Remembering to first identify the type of data that we have and then following the splat method. So having a scale, plotting my data, having those labels on each axis, making sure I'm only using the averages and having a title. All right, guys, have a go at drawing some graphs yourselves. Best of luck.